Hey guys, this is Mr. Kohler again. Just wanted to specifically go through with you what kind of stuff that you have to memorize in terms of units for measure. So basically the stuff that we're going to use a lot in chemistry. The SI units, there's only 7 of them, and what that basically means is there's an international standard unit that we have decided that we're going to use to reference all the rest of the units in the world. The International Bureau of Standards is located in France. There's also one in Washington, D.C. So for example, a kilogram is our unit of mass. There is a kilogram that all kilograms in the rest of the world are based from that 1 kilogram, and it's sealed under a humidity controlled, temperature controlled environment. No air can get to it and stuff, so that kilogram stays a specific weight. This is overwhelming, okay? These are the only things that we call standard science units. All these other units are based on come from these. So some multiplication or division of these. And they get pretty crazy as you get further and further into science. Don't worry about it too much. When we use dimensional analysis, so we're doing factor label stuff, the units will actually kind of take care of themselves a little bit. Now, what do you need to actually memorize? You don't need to know all of this stuff. Okay, those are derived units. You do need to know the kilogram, that's the unit of mass. The meter we won't use much, but you need to know the standard unit for time is the second. International unit for amount of substance is the mole. Whoops, that moved a little bit. We might get to ampere, that's the standard unit for electric current, and we'll definitely use this one, Kelvin, a lot. The one we definitely won't use in here is candela. That's luminous intensity, so you don't have to worry about that one. Okay, another objective that you had in there underneath measurement is you got to understand the difference between mass and weight. Okay, mass is a kilogram. By definition, it's the amount of inertia that's there. So we talked about that one centralized mass right there, a kilogram. That's about 2.2 pounds. That all governments have that are International Bureau Standards. Weight is actually, and so we do this in physics more, a Newton. The problem is the way we measure stuff a lot is you step onto a scale and that's got a spring on it and it's calibrated using gravity so that you can kind of try to determine how much mass is there. That actually varies from place to place in the world, and it's measurable. If you are at the top of a mountain versus down at the near sea level, how far you are from the center of the earth and the amount of ground and type of ground that's underneath you will change that reading a little bit. So what we're going to work with though is the mass. So we want to know how much stuff is actually there, not how much gravity is pulling on you. That's another thing that you're not going to be tested on, so just don't worry about that too much. But I wanted to clear those two things up. Thanks.